We're going to be looking at some different examples to try to deal with this problem that I'm seeing that students are having with fractions. We're going to be comparing improper fractions to proper fractions. Remember, an improper fraction is when the numerator is larger than the denominator, and a proper fraction is when the numerator is smaller than the denominator. I'm having a lot of students who would say that 25/5 equals 5, and they'd also say that 5/25 equals 5, and this is not true. I want to show you this first by just reducing the fractions. I'm going to divide the numerator and the denominator of this fraction by 5 to reduce this to 5/1. So this fraction is equal to 5, so it would be 5 wholes. So I'm not the best at drawing circles, but I want you to get the idea that this 25/5 represents 5 wholes. Now 5/25, on the other hand, when I reduce it, we end up with 1/5. And 1/5 is not even a whole, it is a part of a whole. So let me try to divide this up into fifths. 1/5 would just be one piece, one slice, one part of a whole. It's not even a single whole, it's less than a whole, it's a piece of the pie. 1/5 is actually equal to, as a decimal, 2/10, or you could say 0.2. So when you have a numerator that is smaller than the denominator, this fractional piece is going to be equal to a number that is less than 1. But if you have a numerator that is greater than the denominator, then you have a fraction that is greater than 1. Let me show you another example. 27/9, I'm not going to show you all of the work. Otherwise, it would take forever if I showed every step. I just want to show you that this reduces to 3/1 and equals 3, but 9/27 reduces to 1/3, which is equal to a decimal value, so 0.3 repeating. Remember, when you put a line over it, means that the pattern goes on forever. So that 3 goes on forever. So this number, this fraction that has a larger numerator than denominator, is greater than 1. It's equal to 3. But this fraction that has a numerator that is smaller than the denominator is equal to a fraction that is less than 1. So this is less than 1. It's equal to just a third. All right, our final example, 16/8 and 8/16. A lot of kids would say, oh, those both equal 2, and that is not true. Take a look. 16/8 reduces to 2/1, which equals 2. But 8/16 reduces to 1/2, which is equal to 5/10, or decimal 5. So 8/16 is less than 1. It's not even a whole. But 16/8 is greater than 1. It's equal to 2. So I want you to keep in mind that when the numerator is smaller than the denominator, your result is going to be less than 1. But if the numerator is greater than the denominator, then your answer, this fraction, is going to be greater than 1. Now, there's going to be other situations. For example, if you had the numerator and the denominator were equal, well, you would get a value that is equal to 1. 16/16, if both the numerator and denominator are equal, the value equals 1.